Hi students, welcome to physics classes. Now we are discussing junior inter long answer questions. Today we'll discuss third question. What are the collisions? What are the collisions? Explain possible types of collisions. Collisions, types of collisions. And develop the theory of one-dimensional elastic collision. One-dimensional elastic collision. This is the question. What are the collisions? First we will discuss what are the collisions. Now collisions. Collisions means generally we'll say one object hits the another object. When one object hits the another object, we can say collision takes place. Now here collision means a strong interaction between bodies. A strong interaction between bodies. Strong interaction between bodies means one object hits the another object. Strong interaction between bodies, and it takes place in very short interval of time. Very short interval of time. It takes place in a less span of time. Short interval. Short interval of time, and which involves exchange of momentum. Involve exchange of momentum. Exchange of momentum. Momentum singular, momenta plural. Now when one ball is at rest, another ball hits that ball. Maybe the second ball come to rest and first ball starts moving. Means first ball, this ball to that ball, momentum is exchanged. For example, if a ball is at rest, or moving slowly, now another ball comes and hits to the second ball. This is, for example, if you take, this is the first ball, this is the second ball. Now first ball is at rest, second ball hits the first ball. Now second ball may be coming to the rest and first ball starts moving, or both are moving with a speed. So here second ball to first ball, momentum is transferred. Second ball to first ball, momentum is transferred. Whenever first ball is at rest or moving with a less velocity, second ball comes and hits to the first ball, then what will be happen? First ball starts moving with more speed, second ball may be coming to rest, means second ball given some momentum to first ball. Okay, that is collisions. A strong interaction between bodies and takes place very short interval of time, and they involve exchange of momenta. Now types of collisions. Now types of collisions. Types of collisions. Two types of collisions. First one is elastic collisions. Second one is inelastic collision. Elastic collision and inelastic collision. Collision means interaction between two bodies, strong interaction between two bodies and exchanging their momentum, and it takes place in very short time. Now here during collisions are divided into two types: elastic collisions, inelastic collisions. Now in elastic collisions, during collision, elastic collisions, both momentum and kinetic energy and the kinetic energy are conserved. Momentum and kinetic energy are conserved. In elastic collisions, both momentum and kinetic energy are conserved. Conserved means simply we can say constant. Before collision and after collision, both momentum and kinetic energy will be constant, conserved, remains same. Total momentum before collision, total momentum after collision, or total kinetic energy before collision, total kinetic energy after kinetic energy are conserved. Both momentum and the kinetic energy are conserved. It is remains same. In inelastic collisions, only momentum is conserved. Means only momentum is constant, conserved, remains same. It may be exchanged from one object to another object, but total momentum will be conserved. Not kinetic energy. Kinetic energy is not conserved. Kinetic energy is not conserved. Only momentum is conserved. Remember, in elastic collisions, both momentum and kinetic energy are conserved. In inelastic collisions, here no space. Inelastic collisions, only momentum is conserved. In inelastic collisions, only momentum is conserved. Kinetic energy is not conserved. Elastic collisions, both are conserved. Remember, elastic collisions, both are conserved. Momentum and kinetic energy, both are conserved. In inelastic collisions, only momentum is conserved, not kinetic energy. Kinetic energy is not conserved. Now, examples. Elastic collision example, collision between gas molecules. Collision between gas molecules. In inelastic collisions, example, collision between bullet and its target. Bullet and its target. Example, when bullet hits the target, or gas molecule, one gas molecule hits the another gas molecule, is elastic collision. Bullet hits the target is inelastic collision. Now, next one dimensional elastic collisions. Now we will consider two bodies of masses m1, m2. A mass is m1, for body B mass is m2, moving with their initial velocities u1 and u2. Now they got collision. M1 and m2 get collision. After that collision, they are moving, velocities are changed. Then their velocities v1, v2. Initially velocities are u1, u2. Now after collision velocities are v1, v2. Now according to law of conservation of momentum, total momentum before collision is equal to total momentum after collision. P means momentum. Total momentum before collision equal to total momentum after collision. Total momentum m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. total momentum before collision m1 u1 plus m2 u2, after collision m1 v1 plus m2 v2. We can take it as equation number 1. Next, I am writing m1's one side, m2's another side. m1 u1, this is coming this side, minus m1 v1 equal to m2 v2, this is coming this side, minus m2 u2. So if I take m1 common, u1 minus v1, m2 common, v2 minus u2. Let us take it as equation number 2. This is law of conservation of momentum. Now if we take law of conservation of kinetic energy, total kinetic energy before collision equal to total kinetic energy after collision. Total kinetic energy before collision equal to total kinetic energy after collision. So for before collision, half m1 u1 square, half m2 u2 square, half m1 u1 square plus half m2 u2 square equal to, after collision, half m v1 square, half m v2 square, m2 v2 square, m1 v1 square, half m1 v1 square plus half m2 v2 square. Total kinetic energy after collision. Now half we can take common, and half we can take common, gets cancelled. Then remaining is m1 u1 square plus m2 u2 square equal to m1 v1 square plus m2 v2 square. Like this, if we write m1s are one side, 2s are another side, m1 u1 square minus m1 v1 square equal to m2 v2 square minus m2 u2 square. So if I take m1 common, u1 square minus v1 square equal to m2 common, v2 square minus u2 square. This can be taken as equation number 3. Now equation 1, m1 into u1 minus v1 equal to m2 into v2 minus u2. Equation 3, m1 into u1 square minus v1 square equal to m2 into v2 square minus u2 square. So we can take the ratio. Equation 3 divided by 2 gives 3 m1 u1 square minus v1 square equal to m2 v2 square minus u2 square divided by 2 m1 u1 minus v1 m2 v2 minus u2. So here it is a square, a square minus b square form. We can write a plus b into a minus b. So u1 minus v1 into u1 plus v1. Before that we can cancel m1, m1, m2, m2. So here what is remaining? u1 plus v1 into u1 minus v1, a plus b into a minus b, by u1 minus v1 equal to same v2 plus u2, v2 minus u2 by v2 minus u2. So we can cancel same terms. So what is remaining? u1 plus v1 equal to v2 plus u2. Now we have u1 plus v1 equal to v2 plus u2, v2 plus u2. So here we should find v1 value and v2, formula for v1 and formula for v2. So that to find v1, first I am writing v1 equal to, v1 is here, then v2 plus u2 minus u1 can be taken as equation 4, and v2 equal to u1 plus v1 coming this side minus u2. This is equation 5. Equation 4 and equation 5. Now to find v1, first we should find v1. To find v1, I am taking equation number 1 and 5. 1 and 5. I'll write here what is equation 1. m1 u1 plus, what is equation 1? m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. Total momentum before collision equal to total momentum after collision. This is equation 1. Now what is fifth equation? Just here we have v2 equal to u1 plus v1 minus u2. So this one will substitute instead of v2, in place of v2. Now what we will get? m1 u1 plus m2 u2 equal to m1 v1 plus m2 into, instead of v2, instead of this v2 I am substituting this entire equation, u1 plus v1 minus u2. Let us multiply m1 v1 plus m2 u1 plus m2 v1 minus m2 u2. Minus into plus becomes minus. Now here this side we have m1 u1 plus m2 u2. Okay. Now this minus m2 u2 coming this side plus, already m2 u2 is there. So m2 u2 is here, this side minus m2 u2 is there, that is coming this side, it becomes plus. So we can write m1 u1 plus m2 u2 plus m2 u2, 2m2 u2 equal to m1 v1 plus m2 u2 plus m2 v1. Here v1 is there, here also v1 is there. So we can take common m1 plus m2 into v1 plus m2 u2. Now once again see here m1 u1 plus 2m2 u2. This m2 u2 is coming this side, minus becomes plus m2 u2 plus m2 u2. So 2m2 u2 equal to m1 v1 as it is written, m2 u1 m2 v1 as it is written. This is m2 u1. So from this m1 v1 m2 v1 I am taking v1 common, m1 plus m2 u1. Now this m2 u1 I am taking to this side. So first I am writing this one, m1 plus m2 into v1 equal to, this is coming this side, m1 u1 plus 2m2 u2 minus m2 u1. Just I shuffle the terms. Once I can see m1 plus m2 into v1 I kept like this, m2 u1 coming this side becomes minus. So LHS RHS I written, RHS LHS I written. Now m1 plus m2 into v1 as it easily I written equal to m1 u1 plus 2m2 u2 minus m2 u1. Then here from these two can we take u1 common? m1 minus m2 into u1 plus 2m2 u2. So this m1 plus m2 is coming this side. v1 equal to, here it is multiplying, coming this side divides. m1 minus m2 u1 plus 2m2 u2 whole divided by m1 plus m2. So this we can write as split form. m1 minus m2 by m1 plus m2 into u1 plus 2m2 by m1 plus m2 into u2 bracket. v1 equal to m1 minus m2 by m1 plus m2 into u1 plus 2m2 by m1 plus m2 into u2. This is formula for v1. This is the formula for v1. Now for v2. Now to find v2, we will take equation 1 and 4. What is equation 1? m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. Now equation 4 is v1 equal to v2 plus u2 minus u1. So v1 will substitute here. v1 value will substitute here. So it becomes m1 u1 plus m2 u2 equal to m1 into, instead of v1, v2 plus u2 minus u1 plus m2 v2. So like previous, we will multiply this inside. m1 v2 plus m1 u2 minus m1 u1 plus 2 v2. So at this side, m1 u1 plus m2 u2. m1 u1 minus m1 u1 like previous. This is coming this side. m1 u1 plus m1 u1 minus coming this side becomes plus. So 2m1 u1 then plus m2 u2 equal to m1 v2 plus m1 u2 plus m2 v2. So from these two I am taking v2 common, then m1 plus m2. What we should find here? v2 we should find here. So v2 I am taking common, then remaining is plus m1 u2. This m1 u2 also I am taking to this side. 2m1 u1 plus m2 u2 minus, this is plus here, coming this side minus m1 u2 equal to v2 into m1 plus m2. So this I am writing LHS, this I am writing as RHS. v2 into m1 plus m2 equal to 2m1 u1 plus m2 u2 minus m1 u2 I am taking common, so m2 minus m1 into u2. This m1 plus m2 coming this side. v2 equal to 2m1 u1 plus m2 minus m1 into u2 by m1 plus m2. Now we can split it. 2 into m1 by m1 plus m2 into u1 plus m2 minus m1 by m1 plus m2 into u2. This is for V2. So we derived formula for V1 and V2. Thank you for watching. Please subscribe.